Good afternoon, my YouTube viewers. It is Crystal here. I wanted to make another video for you. The video that I'm going to be making for you is going to be about the exponential distribution and the test that you can perform on it. And so basically, what I've done is I've used Python and Excel to create 3 exponential distributions. And you can see I've created the means of the 3 exponential distributions. The alpha is 0.05, and then you've got the null hypothesis, which is the samples are the same, and the alternate hypothesis, which is the samples are not the same. And then so I've tested the exponential distribution using the kolgomorov-smirnov test for 2 samples, the Anderson-Darling test for 1 sample using stats modules, and the likelihood ratio test as well. And so basically what I'll say is the only readings that I really trust are the kolgomorov-smirnov test. The Anderson-Darling, it gave me a p-value of 0, and the likelihood ratio test that gave me a p-value of 0 as well. So I'll show you the code, and you can use the code and see if you can get it to work. But because it gave me a p-value of 0, I don't really trust it. I would just rather stick with the kolgomorov-smirnov test for 2 samples. Okay, so the first thing we're going to do is we created a distribution. So this is the Python code that we use to create the distribution. I also want to say in the very first spreadsheet of this workbook, what you need to do is you need to import all of the libraries that you're going to need. So over here you've got import libraries, and so I've got from scipy.stats import expon and then norm. What I've done in this particular instance is because I have one spreadsheet that's really big that's got all of my distributions in them. It's the one thing that I've noticed about Python is it's not a very memory friendly program, and because it's not a very memory friendly program, what I've had to do is I had to take the spreadsheet that I was working on, and then I had to copy it into another file called work in progress. And this other file called work in progress has just got that one page on it where it will work. But because Python just can't cope with all that data, which is a shame. It should be able to cope with all the data. If you're allowed to have, I think, like 255 pages and a spreadsheet, in theory, Python should be able to cope with that, but Python can't cope with that. And so the only way that I can get it to work quickly, because that's what it's all about, working quickly, is I can only have like one page to the file. And the thing is that but I just have the one spreadsheet, and it just takes ages and ages and ages to have all those pages in it, because it's trying to compute everything all at once, which is what's causing problems. So that's what I would recommend you do if you want to. The way I do it is I have one workbook just with all the distributions in it, and it's not got that many pages. I mean, the way Python is acting, you'd think I'd have like 100 pages or something, but I don't have 100 pages. And then if you want to use that page, take that page and copy it into an empty workbook. So you're only working with the page where you import the libraries and then the page of the distribution, and then it'll work. It won't work if you don't do that. That's what I found out. So we've got our image. We're going to create 3 exponential distributions. We're going to go over the code for one, because the code for all three are the same, except it's going to be exp1, exp2, and exp3. So where the scale equals 1, the sample size equals 1,000. The exp1 equals np.random exponential scale, comma, sample size. And then we plot the distribution, and you can see that this is a right skewed distribution. So plt.hist exp1 edge color equals black, plt.title exponential distribution, plt.x label is scale, plt.y label is size, plt.grid is true, and then you've got plt.show, and that shows you get a little, you've got your distribution, and then you even get a tiny little picture of the distribution in the cell. And if you want the distribution to be larger, then what you would do is you would merge the cells. You would merge a whole bunch of cells together to make one large cell, and then you could have one large cell in the distribution. But I wanted to do hypothesis test on it, so I'm more interested in the actual distribution than a picture of the distribution. But I did like you can see a tiny little exponential distribution in the cell. So then what I wanted to know was the means of the three exponential distributions. So the means are very close together, 0.98, 1.0053, and 1.0305. So you can see the means are very close. And since the means are very close, in an ideal world, it would accept the null hypothesis, because the null hypothesis is that the samples are the same, and the alternate hypothesis is that the samples are not the same. So we're going to check the kolgomorov-smirnov test for two samples. I'll give you the code for that. So the statistic p-value equals ks underscore two samples, exp1, exp2, and then you've got your statistics p-value, which our statistic is 0.029 and your p-value is 0.79, and that is telling you that you're going to accept the null hypothesis because it's higher than the alpha, and the alpha is 0.05. So let's just say hypothetically, since this is working quickly now, let's just say hypothetically we're going to say scale of 5. Okay. Okay, so it's just working. See, you can see how long that it takes to do anything, and because it takes such a long time to do anything, that's why I had to take the page and copy it onto a blank workbook. But you can see when we changed on EXP2, when we changed it from 1 to 5, you can see that our statistics is 0.526, and the p-value is a very low number. But what we'll do now is we'll change it back to 1, because I just wanted you to see what would happen if you changed it. Now we're going to check the Anderson-Darling test. And the Anderson-Darling test, this is the code for that. Statistic p-value equals normal AD, and exp3 axis equals 0. So what we're doing is we're checking the distribution number 3. And so it gives you a number of 46, but it gives you a p-value of 0. And I don't really trust it. And I think that normal AD means it's supposed to be for a normal distribution. And this is not a normal distribution. This is an exponential distribution. And so we're going to check the likelihood ratio test, which the null hypothesis exponential distribution is null params equals expon dot fit exp1, And I think that is a stats models. No, it's not a stats models, it's a SciPy. And then let's see what we've got here. So we've got norm, we've got SciPy, and we've got stats models. So normal AD is stats models, and the other one is going to be norm, exponential, and norm. So no, log likelihood equals np.sum expon.log pdf exp1 comma times null params. Alternative hypothesis, normal distribution as an example, alt params equals norm.fit exp1, alt log likelihood equals np sum norm log pdf exp1 alt params. And now we calculate the likelihood ratio test statistic. So your LR, that's likelihood ratio statistic, equals 2 times alt log likelihood minus null log likelihood. And then the 2 times means that it's giving you what it's doing, it's giving you 2 tails. If it's a 2 times, it's giving you 2 tails. And then what I did was I calculated the p-value because the p-value wasn't in there. And so I just looked on the internet to try to find a calculation for the p-value. And I used the function for the z-statistic to get the p-value. So p-value equals scipy.stats.norm SF ABS, that's absolute value, LR statistic, and then so you're going to give you the LR statistics and the p-value, and again it gives you a p-value of 0. So I don't really trust that either, but I decided to go ahead and show it. So if you want to experiment with it, you can experiment with it and you can find out what it's really supposed to be. So the only test that I personally am going to trust is going to be kolgomorov-smirnov test for 2 samples. And see, basically what happens is what happens is you need to pick your test wisely because the test might not be appropriate for a distribution. And the simple fact that we're getting 0 p-values on 2 of our tests, well, that tells me that maybe it's not a good test to use for this distribution. But kolgomorov-smirnov test is a good test to use. I use that test a lot in machine learning, and I've used it quite a few times in the videos that I've made, and it's come up good quality readings every single time. So that's it for the exponential distribution and hypothesis testing. So I'm going to go ahead and conclude this video. If you like my video, please like and subscribe. Thank you very much for watching my video, and I will be communicating with you in the next video where we will be talking about some more statistical concepts.